Hi, I'm Mr. Evans, and in order to introduce our energy unit, we are going to start by talking about potential energy. Now, although there are tons of different types of potential energy, such as chemical and electrical, we are going to focus on one type of potential energy today, which is gravitational potential energy. And so gravitational potential energy is the energy due to where something is compared to usually the earth or at least some kind of ground. So even if you're in like a second-story building, the gravitational potential energy would be to, the floor you're standing on, even though that isn't all the way to the ground. And so this is the energy it has due to that. And so, some examples would be if something was stuck in a tree, that would be gravitational potential energy. So if a bird lands in my tree over here, then I have gravitational potential energy. If a person is playing basketball and shoots the ball at the hoop, the minute that ball is in the air, it has gravitational potential energy. Okay, so once it's off the ground, even if something is holding it, so same with the bird in the tree, is actually sitting on something, let's say it's sitting on a branch, it still has gravitational potential energy. And what we're really going to focus on in here is the math side of gravitational potential energy. And so our math equation for this is potential energy equals mass times gravity times height. Okay, and mass is always measured in kilograms, so that's something we'll have to pay attention to, right? If we're in some other unit, we got to get to kilograms. Gravity, this one's an easy one because it is always 9.81 every time. So I'll always give that to you on a test or a quiz, but we'll use it so much here that eventually you'll just have it memorized. And you won't be thinking twice about it. And height is always in meters. So again, being in the United States, we use feet and inches and stuff, and I might even give it to you in the question as feet and inches, but all that means is you have to convert it to meters. Once you have your units in kilograms, meters, and potential energy will be in joules, you can solve for your unknown. So let's go ahead and do a couple practice problems. Go ahead and clear off my board here. And I'll put the equation back on top here just so you kind of have something to reference. Potential energy equals mass times gravity times height. Okay, and again, it's important to remember those units that you need to be in. Okay, so now you can see off to the right I've added a question, and so our question is how much potential energy, and so right there's our question, right? How much potential energy? So we're solving for potential energy. Does a 0.6 kilogram football have that is 10 meters off the ground? So the person threw it, or maybe it's stuck in a tree. Either way, it's 10 meters off the ground, which is actually pretty high. So they really threw that football into the sky. Maybe not the best number for me to come up with. So the first thing I would do is make sure we're in our units. And so mass needs to be in kilograms, and I can look over here and see we're in kilograms. And height needs to be in meters. And so I'll come over here and clearly see that we're in meters. So we're good to go right now. From there, we don't know potential energy. That's our unknown. And so I'm just going to plug in our knowns. Mass, 0.6. Gravity is always 9.81. And height is 10. Now that I've plugged in all of my numbers, all I have to do is multiply them across. And I find out that that football has a potential energy of 58.86 joules. Okay, and that's a pretty small number as far as energy goes. A lot of the time energy is mentioned in kilojoules, and so this would be 0.058 kilojoules, and that's not very much. When I think of energy, I think of how likely this object would be to hurt me if it was to fall. So if a football falls from a tree and hits me, I'll feel it, and I'll feel the 58 joules of energy, but I'm not going to be seriously hurt. Compared to if something like a car was stuck in a tree, that's a lot more mass, which makes this number bigger, which makes this number bigger, which results in me getting hurt. Okay, so I'm going to go ahead and do one more practice problem with you. And this time I'm going to make sure we have to convert units just to make it one more step further. Okay, so I have my new question written. And it says, you know, we're looking for the potential energy of a 65,000 gram person that is 2 meters off the ground. And so when I pictured this question, I was picturing somebody on a swing set, and you know, they're on the upswing and they reach that maximum height, which is, you know, maybe about 2 meters. And the person weighs 65,000 grams. So again, you know, I'm asking for potential energy, so that's our unknown. From there, if you remember, step one was to make sure we're in the correct units. So, you know, I'm going to check. We have 65,000 grams. That is not the correct unit. And so before I even go any further, I'm just going to go ahead and convert it before I forget. So we have 65,000 grams. And I need to convert that to kilograms. And I know that kilograms is 10 to the third, which means moving the decimal place over 3 spots. So we go 1, 2, 3. And so what we actually have is 65 kilograms. Now, if that confused you, if converting right here from grams to kilograms is tricky, I'm not going to elaborate on this further, but there is a separate video that I have called Unit Conversions that's in the year-long folder. So go ahead and reference that, and you can feel free to watch it. Moving forward, though, we have 65 kilograms. My other dimension is in meters, which is correct. And so now I can plug in all the numbers. And so I'm going to come over here and start doing my math. So we have potential energy equals mass, which we solved to be 65, gravity, which is 9.81 every time, and height, which is 2. So this equals 1,275 joules of energy. And so what's cool to see here is, you know, how significant, you know, something like mass can really affect potential energy. And so in our previous question, we had a football that was 5 times higher off the ground, but way less in total energy due to the fact that a person weighs way more than a football. So, you know, hopefully that helps explain potential energy. Our next video will be kinetic energy, which would be the energy due to motion.